This video is about a well-known flat earther's confusion about what is eye level, can we measure the horizon dip, and does camera tilt affect this? And later I will show a video that camera tilt has absolutely no effect at all. How this got started was a few days ago. Rory put out this really good video showing a variety of ways that the horizon dip can be measured. Well, on the same day, Phuket Word saw this and he put out this video. Bad flat earth high level horizon examples in misdirection. Every photo used by Rory easily debunked. Well, his debunking in every case was that the measurement was not exactly in the center of the frame, so therefore it was not level. So the first thing we need to do is talk about what is eye level. Now, from a surveyor's standpoint, what you do is that you have a plumb bob, and a plumb bob will make a perfectly vertical line to the surface of the earth. So eye level would be a perfectly horizontal line that is perfectly perpendicular to this plumb bob vertical line, exactly 90 degrees. And on a flat earth, this would be a level parallel line above the flat earth. And due to perspective, what we would see is that it would appear that the ground would rise up to eye level. On the globe, the definition is exactly the same from the observer's position. The only difference is that, of course, on the globe, we have a surface that curves away, and this is what causes the dip of the horizon. Now, the question is how do we measure eye level? And this is what Rory brought up in his video, is that flat earthers never measure it, they just assume it. So let's listen to what Rory says, and we'll listen to Phuket Word's response.
A lot of the flat earth diagrams and memes, they don't really have any, well, they never have a measure of where eye level is.
Now that's false. Eye level, as we've just explained, is when the camera is horizontal, just like a theodolite should be, looking directly ahead, and the eye level will be the center of the field of view only when the camera is looking straight ahead, horizontal. Okay, so that's the measure.
So Phuket is somewhat right here. Eye level is when the camera is horizontal, just like a theodolite. Eye level will be the center of the field of view only when the camera is horizontal. But this is the point. Exactly how do we know when the camera is perfectly horizontal? Now here I have it. So there's a camera set up with eye level, and in this case, the center of field is right in the middle of it. But the camera is not a theodolite. There's no measurement in the frame, so we don't know if the camera is actually a little bit higher or a little bit lower. And unless there's a method of measuring this, you cannot just make an assumption that it is level. And this is one of Phuket Word's videos, and this is what he does. He points a camera at the horizon and go, look, the horizon is at eye level. Well, here is the center of frame in this photograph, and I could now make the claim that, look, horizon is below eye level. But the reality is I don't know where eye level is, and neither does Phuket Word, because he did not measure it. Like Rory says, he just made an assumption that the horizon is at eye level. So Phuket Word agrees that a theodolite could accurately measure eye level, and that's exactly what these instruments are designed to do. Once they are properly set up, you look through the telescope, there's a crosshair, and the horizontal one will be perfectly aligned with eye level. So Rory used a theodolite as one of his examples. You can see the crosshairs here exactly in the frame center. We can clearly see the horizon is below eye level. So let's see what Phuket Word's response is to this.
I mean, it's just obvious that they're just I don't know, they're just pointing it up, looking at something very, very far away.
So you do gotta laugh because even though he claimed that yes, a theodolite will accurately show eye level, when he sees that it correctly shows there's a dip in the horizon, he's just not going to accept reality at all. Another way of measuring eye level is with a water level. This is a very simple device. All we need to do is get a plastic tube, fill it with water, and we know both ends are perfectly level. So when our line of sight shows these two ends in alignment, we know that we are at perfect eye level. So now all we need to do is set up a camera and take a photograph of this. Now the nice thing about this is camera tilt does not affect eye level. If the frame center is either higher or lower and we still have this line of sight in the photograph, then it is the water level that will establish level. In the upper case, we have the camera center higher, so we will see eye level lower in the photograph, and the reverse is true on the bottom diagram. Now camera level does affect parallax, because if the camera is either higher or lower than this line of sight, then it's not taking a photograph of it. So we will not see the water at both ends in perfect alignment. So next we're going to show a video clip from Rory where a water level is used, and let's see what Phuket Word has to say.
No, it hasn't. Yeah, here is, hopefully you can see this. All right. Yeah, there's the center of the photograph, and the eye level is actually below the level of the water level. Okay, so it's wrong, it's not level.
So again, Phuket Word did not accept the results, and this time it's because here is the center of the photograph and eye level is actually below the water level, even though we see the water level in perfect alignment. So it's wrong, it's not level. Again, another assumption. Now, if Phuket Word wanted to do some science, what he could have done is set up his own water level. They're not expensive, a plastic tube and water, and then he could have aligned the center of the picture frame in perfect alignment with the water level and showed us that yes, now we see the horizon at the water level. But of course he did not do this because he just makes assumptions. So this is what I did. I went to the top of a 370-foot building and I set up a water level. You can see the black line in the middle is the center of frame. You can also see the horizon. The camera is focused on the water level, that's why the background is a bit blurry. Now you can also see a vertical line here. This is a distant chimney of a refinery, and the water level is almost in perfect alignment with the top of that. So what I'm going to do is I'm going to play a video. I'm going to tilt the camera up and down, and you're going to see that there is absolutely no change of the relationship of the water level to the chimney or to the horizon. So I'm tilting the camera up, and you can see no parallax change at all. That water level perfectly defines eye level. Now we're passing through the center of frame, the camera's being tilted down, and again, absolutely no change in parallax. Phuket Word is wrong. So it's exactly like I showed here. When the frame center was high, we could still see eye level. It was just below the frame center and vice versa. So my video showed that the water level always correctly showed where eye level was, and Phuket Word is wrong. Camera tilt did not affect this. The center of the picture frame is not eye level and has nothing to do with eye level. So next I'm going to have a short clip where I elevated and lowered the camera, and now we will see a change in parallax. So now we see parallax change. These two screen captures clearly show the change in parallax because we no longer see the water level in alignment in either photo. And when the camera is above eye level, we actually see this drop much lower, and we see the exact opposite down below. So in conclusion, Phuket Word provided absolutely no measured evidence that the center of the camera frame has any relation at all to eye level. And he also did not show that camera tilt affects parallax. In fact, my video shows that it does not. What Phuket Word did is like every other flat earther, he points a camera at the horizon and go, look, the horizon is at eye level. Well, this is an assumption. This is pseudoscience. So actual measured evidence in both Rory's and this video debunked Phuket's Word claim. The horizon does not rise to eye level. We measured it and we showed it. This is some more evidence on my channel. I uploaded this video last week atop the same building using a water level and clearly showing the sun setting below the water level or eye level. I have a link in the description if you want to watch it. Now it's quite humorous because later in the day, Phuket Word put out this video. Childish hypocrites fight flat earth with shoddy pseudoscience. And this is in his description. You're a childish hypocrite if you fight flat earth with accusations that flat earth researchers don't do science. You know, I think I just made a video showing that you did not do science. You made an assumption, yet defend the shoddy pseudoscience and deception used to prop up the imaginary globe earth belief. I think mine was a pretty good demonstration using science to show that there is a dip of the horizon. My suggestion is wake up and smell the coffee. We live on a globe.